All right, last chapter, kids. Hey, the last chapter is the easiest one. Trust me, 4 and 5 has got a little bit of meat to it in terms of writing electron configurations and doing some math. This chapter is an easy chapter, so feel pretty good about this. Not saying blow it off, but get your easy points. You should have been given the outline by the sub. So let's just talk about the development of the periodic table and what's going on. Now, the periodic table on the wall took a few hundred years or 150 years or so to develop. It didn't just fall into place like that. So it started, as you can see, with A1, this guy named Doberner, and I may be pronouncing that wrong, but basically what he did is he tried to arrange every 3 elements and find out if they were alike. You know what? And it worked for the few, dozen, 15 elements that they knew about, but once we started discovering more elements, it didn't really work. So 50 years later or so, a guy named Newlands, I believe he was English, came along and arranged all the atoms in terms of atomic masses, lowest atomic mass to highest atomic mass, and he found that every 8 elements acted alike. Hence the name law of octaves, because oct means 8. So on page 139, check that out. If you need to pause it. But on 139, they're showing in this chart here lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and sodium. Every 8 elements had similar properties. And you know what? That's true. All these elements right here, lithium, sodium, potassium, have very similar properties. They're all very reactive with air and water. In fact, if you throw them in water, they will explode. If you get bored after the video, go ahead and Google alkaline metals in water. Alkaline metals in water. And you see a couple videos, pretty cool videos actually, of things blowing up. So the elements in the same columns have similar properties. For instance, fluorine and chlorine are both very noxious gases, meaning nasty gases, very harmful to humans. They have very similar properties. But what we found is after we created more elements, Newland's law of octaves just didn't work. So along came the father of our periodic table, Mendeleev, which is Roman numeral 1b. Mendeleev is the dude. He is the one who's given credit for our periodic table. Now what he did is he also arranged it by atomic mass. You can see in number 3 here. But what he did, which was special, is he left blanks in his periodic table. So, for instance, they didn't know about the element germanium. Right here, germanium. So what he did is when he created his table, instead of jamming arsenic over here, he left a blank. So imagine there was nothing there. And what's really cool is he was able to predict the properties of germanium. So you should still be on 139. If you look at the bottom of 139, look at the properties of ecosilicon, what he called it. He predicted the atomic mass, melting point, density, and then look what it was later when they discovered it. Look at how close everything was. Now that is why Mendeleev is given credit for our periodic table, is because he was able to predict the properties of elements that we had not discovered. Okay, that's kind of a big deal. Now Mendeleev arranged his according to atomic mass. These are these numbers down here. Remember, you learned how to calculate those. Now today's periodic table looked a lot like Mendeleev's, except today, modern periodic law, we arrange them according to atomic number, not atomic masses. So there would have been a few elements that are switched around, but today we're arranged by atomic number. Mendeleev did it by mass. Okay? So what should you know about today's periodic table and how it's arranged? Okay? Get up. I hope you still have your books out. Turn to page, this is me looking through my book. Can you hear me turning pages? Look at page 155. 155, and you'll see this table. Here are some things you should know in the periodic table here. You should know that the up and down columns are called families or groups. The reason they're called families or groups because they have similar properties, just like sisters or brothers in the same family have similar characteristics. Not exactly the same, but similar. You can see similar features in siblings. So fluorine, chlorine, bromine, iodine, and astenine here all have very similar properties, as do the noble gases. The noble gases are all unreactive or inert, essentially. So they're all in the same column. And that's true all over the periodic table. If you're in the same family, you have the same number of valence electrons, and since you have the same number of valence electrons, you act like everybody else in your family. So there are a bunch of different names. You should know the names of these different families. So on a test, I will say, what element, which of the following is a noble gas? Or which of the following is a halogen? The halogens are right here. Perhaps you've heard of halogen bulbs, halogen headlights, okay? The rows here are called rows or periods. The rows or the periods, like we've been looking at since we did electron configurations, tell you the number of shells. So everything in the same row has the same number of shells. So if I give you something like mercury right here, number 80, you should be able to tell me how many shells. And the answer is 6 because it's in the 6th row, so it has 6 shells. So up and down, we got families or groups. Side to side, they're called rows or periods. And then, other than that, you should know that the metals, there's a staircase on your periodic table, but there's a staircase that you'll see on many periodic tables that separate metals from nonmetals. I hope this shows up okay. Sorry for the glare. Right here, there's a staircase, and if that staircase should be on your periodic table also. This separates the metals from the nonmetals. Metals have properties like they conduct electricity, and they tend to be lustrous, which means shiny. They also tend to be malleable, means you can bend them, you can pound them, they won't break. Nonmetals are the opposite. They're non-conductors. They tend not to be malleable, and they're not shiny. They tend to be dull. If you've ever seen coal or your pencil lead is made out of carbon, it's very dull, okay? Now, the elements bordering the staircase are called metalloids. I'm sure you'll read about this in your book somewhere. I don't know what page exactly. Oh, I see it on page 156. A metalloid are the elements bordering the staircase here. Now, it's not all of them, but it's many of them. For instance, silicon. Not silicone, my friends, but silicon. You know silicon because it's in computer chips. Remember Silicon Valley? You've heard that term. It's out in California where a lot of tech stuff is created. Silicon is very brittle, like a nonmetal. It's very dull, like a nonmetal. But you know what? It conducts electricity like a metal. So metalloids have properties of metals and nonmetals, kind of like humanoids in sci-fi movies. They look like humans, but they're part robot. So they have properties of both. Like the Terminator. Terminator looks like a human, but he's really a machine. So he's like a humanoid, okay? So a metalloid has properties of metals and nonmetals. And tell you what, that's all I've got. If I were here teaching you, that's about how long my lecture would be on chapter 6. So do a little bit of reading, know your bold print terms, know your transition metals, which are right here. Do a little studying and you should be fine. This chapter is easy peasy. That's it. Chapter 4 through 6 is done. Hopefully you've been doing problems along the way. My answer books are in the back. You should be checking things as you go. If you have questions, use each other and ask the sub. She's got a science background. You should be okay. So we got a test Friday. See you Monday, kids.